In today's lesson, we're going to be looking at the scientific method. I need you to turn to, I believe it's page 11 in your notebook, where we wrote the learning intention last class before doing our hummingbird activities. Those of you that are completing the video lesson, which would be this lesson right now, you don't have to do the science starter as you did not have the full class. However, I do strongly recommend watching this video as it's quite interesting to see what inspired Adam to continue his career in science throughout all these years, and just to see what kinds of questions and curiosities that other people had that helped compel science to what it is today. So underneath your learning intention, you do need to set up Cornell notes. These are the 4 categories that we're going to be looking at. So we're going to look at what the scientific method is, the steps of the scientific method, writing a hypothesis, and then we're going to give you a paper to use to practice the independent and dependent variables. You do not need to write the categories down yet, but we will need you to write them in the key term section, so that smaller column, as we go. When you're done the video lesson, I do recommend going back to the slideshow that was posted on Wednesday and having a look and watching this video here, the scientific method. The first 5 minutes are great for everyone, and then I'd only suggest the last 3 minutes for those that want to go a little bit deeper and into some topics such as correlation and causation and falsibility and that sort of thing. So for anyone that's new to the class, or just didn't have this last time when they were in science, anytime you see this lovely pencil here, that means you do need to write down what is on the page. What's in the title box here, or the category on the left, the scientific method, that goes in the key terms. And then what I need you to do is I need you to write down the definition for the scientific method, or the description rather. So the scientific method is a process for experimentation used to explore observations, find cause and effect relationships, and answer questions. One of the things that it does allow us to do is it does allow us to look at being able to redo the labs, okay, multiple times, and that when we redo them, we'll get the same result. This bottom part here, you don't have to write down, only if you'd like to. Okay, so it allows for reproducibility, meaning that you or another person can repeat the exact same lab, and you should get the same results. So the steps of the scientific method are as follows. 1, you need to observe the world around you and then ask a question. Once you've asked the question, you need to do some background research to find out what's already been done to try and answer this question, as well as maybe get a little bit more information on the topic. Once you've done your background research, you need to construct your hypothesis. So you need to predict what you think is going to be the result, design an experiment and test, and then analyze your results. If your hypothesis is true, you can report your results. If your hypothesis is false or partially true, you need to report your results and go back and try again. Okay, you can always do the try again step before reporting your results, but you will want to keep track of all of your results so that you can provide the whole picture. You don't need to copy these steps down, but you do need to glue the page provided into your notebook. I'd recommend either gluing it sideways or folding it into a smaller amount so that it doesn't take up too much space in your notes. So on these slides, since there's no pencil, you don't need to write it down, but we're going to go through a little bit more in detail of the steps of the scientific method. So the first one is the problem, which is basically the question that you're trying to solve. So from looking around you and observing the world around you and wondering about what's going on and why things happen, how things work, all of our lovely questions, you know, who, what, where, when, why, how. And then in science, we mostly stick to the why and the how. You need to come up with a question that shows what you are hoping to solve through your experiment or research. So we have that pencil again, which means you do need to write down the hypothesis. The hypothesis is basically your prediction. It is an if-then statement. So for example, if this happens, this happening being your cause or your independent variable, then that will happen. Okay, that being your dependent variable. And then you need to explain why you think that. Okay? Try to stay away from using the term I, as we really want our hypotheses to be kind of neutral and not thought to be opinion, but more of an educated guess using your background research. So make sure that you do copy this part into your notes, okay? Then once you've got your hypothesis, you're going to make the procedure. The procedure needs to be step by step. Okay, so 1, do this. 2, do that. 3, this. 4, etc. and etc. until you've got all of the steps done. When you're making your own experiment, I recommend keeping the steps short, okay? After you've made your procedure and you actually run the test, you're going to have some results and data. Once you get your results, which are the observations, okay, of what you saw happen, and you have the data, then we need to analyze it. In our analysis, we'll either be asking you questions or we'll be asking you to turn it into a graph. Finally, just like in English where you're writing an essay or something like that, or social studies, you do need to write a conclusion. So in our conclusion, we're going to follow the format of SWARE, which means summarize what happened, accept or reject the hypothesis, give your reasons for accepting or rejecting the hypothesis, and evaluating your procedure to see if there might be any sources of error or somewhere that could be improved in the future for other people to do the lab. We won't always use the SWARE, but we will basically have questions relating to this. Sometimes it will be questions, sometimes we will ask you to respond in the form of a paragraph. So now that you've got the notes done, you're going to practice identifying the independent and dependent variables using the hypotheses provided. Keeping in mind the hypotheses provided are in the I format, meaning if I do this, then this will happen. We will stay away from that. You can try to reword the hypotheses. That would be wonderful, so that there's no more I. But basically, we need you to glue the page in, and Ms. Souson or I will provide it to you. You need to glue the page into your notebook, and then identify both the independent and dependent variables. As you are not actually going to be in a class setting, you'll be watching this on your own most likely. We're going to have you ignore this class discussion. So that's it for the scientific method. What you need to do now is your exit ticket, or as your homework at home, is to complete your summary using the following prompt. So I'd like you to start off with the scientific method is useful when designing experiments because, and then finish the sentence. All right, that's it. If you have any questions on the scientific method or the brief introduction that we've done, please come and ask us. We will be using the scientific method throughout our different units, so you will be getting more practice. This is just to give you an overview so you know what to expect. Now, if you finished early and you are not moving on to the next part with the forces in motion, what I do need you to do is to work on some of the extensions. So we have some additional reading, and you'll need to go to the presentation in Google Classroom to access the links. But some additional reading on Science Buddies We also have some virtual labs here that you can use to practice going through the scientific method, or you can go into Blend Space here and click on any of the things that's in it to deepen your understanding. And finally, the last thing that you could do is you could actually come up with your own question and design a lab that would be able to answer that.